Hey everyone, it's Dr. Walker. Let's look at this example from video 87 on mathematical description of waves. This example, we have a traveling wave. It's shown at time equals 0 seconds, and it has a frequency of 8 hertz. Notice that the picture of the wave shows us the position, the y position, as a function of the x position. So that's why it has to tell us that it is shown at time equals 0 seconds, and that it has a frequency of 8 hertz, because we cannot get the frequency from this graph because this graph doesn't show time. We want to find a wave number, the period, the angular frequency, and the speed of the wave for part A. So this will be a lot of plug and chug. The wave number k was defined as 2 pi over lambda. So we're going to plug 2 pi divided by the wavelength. We can get the wavelength from this picture because the wavelength is a distance from one crest to another crest, right? The distance between two identical points. So the wavelength is 40 centimeters, which we can go ahead and convert to 0.4 meters. So our answer is going to be 15.7. We did forget to discuss the unit of the wave number. Well, 2 pi is in radians, and the wavelength is in meters. So the unit is radians per meter. Next, we want the period. The period is defined as 1 over the frequency. The frequency was given as 8 hertz. So the period is going to be 0.125 seconds. Next, we have the angular frequency omega. That's defined as 2 pi over the period, or 2 pi f. So 2 pi times 8 hertz. That's going to give us 50.3. Do you remember the units for angular frequency? Think of 2 pi, which is radians, divided by period, which is time, which is in seconds. So radians per second. And then the last one was the speed of the wave. We can use omega over k, or we can use lambda times frequency. Both will give you the same answer. In this case, I'm choosing to use lambda times frequency, wavelength times frequency. So 0.4 meters times 8 hertz is going to give us 3.2 meters per second. You should try it with omega over k just to make sure it gives you the same answer. Now for part B, we want to write a general expression for the wave function. Remember, the general equation that we just learned is y equals a sine kx minus omega t. So all we need to do is just plug in our numbers. So y as a function of x and t is equal to a. What's the amplitude? Amplitude is that height from the equilibrium position, which is going to be 15 centimeters, or 0.15 meters. And then sine, k was 15.7, and then omega is 50.3. So this would be our wave function that represents this traveling wave. So you should be able to write equations based on pictures, or if you are given an equation, you should be able to draw the wave. And if you're given an equation, you should be able to get all of these different quantities from that one equation.